for 18 maximum amount of money robot can earn. So for this problem, let's just make a drawing. So in the first example, let's just use this kind of drawing. So we're gonna have the first row is gonna be 0, 1, and -1, and the second row is gonna be 1, -2, and 3, and for the third row it's gonna be 2, -3, and 4. So we are giving this robot, it is standing at the top left corner, and it will go through the bottom right corner. Yeah. So it's gonna start from here. So for example, it's gonna start from this position and it's gonna reach to the bottom position. And this robot can only go to two directions, go to the right and go to the bottom. And this robot wants to collect as many points as possible. So for the points, it means the value of each of the coin. But there are going to be negative values. This is a little bit difficult. And another one is that there are going to be another value. So for example, we're going to set this value k equal to 2. So this means if the robot find a negative value, so the robot can just set it as 0. So this means the robot will not collect this value -2, but it will consume the value of k. So k gonna become 1. Yeah. So let's just translate this kind of idea. So if the coins is more than or equal to 0, so the robot can directly give that many coins. So if the coins is less than 0, so the robot encounters a robber, and the robber steals the absolute value of the coins ij. Yeah. So this means the value gonna be reduced if it is a negative value. But we need to be careful. The robot also has a special ability to neutralize. So this is the meaning of the neutralize. So the robot can neutralize the robbers. So the robot has a special ability to neutralize the robbers in at most 2 cells on its path. So it means if we set the neutralize value to be 2, this means the robot can use 2 neutralize. So for each of the neutralize, so the robot gonna set this value to 0. So for example, this is a negative value, so the robot can set it to 0. If this is a negative value, so the robot can set it as 0. Yeah. So this is a basic grid DP problem. We can directly use the top left to go to the bottom right corner, or we can go from the bottom right to the top left. It is just similar. And we need to be careful that the values can be negative values. So this means if we go out of the boundary, we're gonna set a negative infinity. Yeah, because inside they're going to be negative values, so we're going to set a negative infinity to make the problem easier. So this means if we go from the bottom right corner to the top left corner, if it goes out of the boundary, we're going to set a negative infinity. Yeah, so this means basically we're going to choose the maximum value. We're going to never choose the negative infinity. So instead of 0, we're going to set a negative infinity. And another part is that we can consume this value too. This is the neutralized value. We're gonna use it at most 2 neutralize. So if we meet a value, it is a negative value, and also for this k, if it is a positive, it means we can still use the neutralize to set it as 0. So instead of setting it to 0, this means definitely we will ignore it. We will not use this value. So it means if the robot goes to here, instead of use -2, so we're gonna just plus a 0. So we will not do anything. So this is the basic idea. I think the problem is just like other robot cleaning or robot collection money problems. Yeah, it is just similar. So let's just prepare. We're gonna prepare R and C. It's gonna be the length of the coins and the length of the coins 0. And let's just use a cas because I'm gonna use the DFS. So I'm gonna set a function. So inside it's gonna be R and C, and I'm gonna set a value as k. So finally I'm gonna call the function. It's gonna be R -1 because I will go from the bottom right to the top left corner. So this is gonna be C -1, and the value of k gonna be and let's just set it as 2. So this means we're gonna have a neutralize time of 2 times of neutralize. So it means if we found a negative value, definitely we can use this neutralize to set it to 0. Now the condition is that if it goes out of the boundary, if r is less than 0 or c is less than 0, we're gonna set a negative infinity. So instead of setting it to 0, because we're gonna choose the maximum value, so we're gonna choose a negative infinity. Yeah, otherwise if it goes out of the boundary, we're gonna choose that value. Because we don't want to choose that value, so we're gonna set it to negative infinity. Now we're gonna check this value. X gonna equal to the coils. We're gonna check the value of the coils, and if r equal to 0 and c equal to 0, it means the robot goes to the top left corner. If it goes to the top left corner, still we need to check, because this value x, it can be a negative value. Yeah, so we're gonna return a maximum value of x and 0 if the k is more than 0. So this means we still have the neutralize ability, because this k is more than 0. So this means if this value x is a negative value, because we have the neutralize ability, so we're gonna choose 0. Yeah. This also means even though we have the neutralize ability, and this k is also more than 0, but if this x is a positive value, so definitely we're gonna choose a positive value. So we will, even though we don't use it, but we still choose the positive value. So this is the meaning of the max x and 0. Yeah. So otherwise, we don't have the neutralize ability, so we have to choose this value x. Now, like the normal robot cleaning problem, so for the result, this means for each of the cell, we're gonna collect the coin. So we're gonna choose the maximum. Yeah, we're gonna choose the maximum of the f r minus 1 with the c and k, because we will not use the neutralize ability. We just collect the coin. So this is we just collect the coin. If we just collect the coin, so another one gonna be f r with the c minus 1 and k. Yeah, so if we were to collect the coin, definitely we're gonna check the coin. So it's gonna be coins, it's gonna be this value x, because we've already prepared. Yeah. Now what are we gonna do? This is for collect the coin. So if we don't want to collect the coin, maybe we want to use the neutralize. So the condition is that if k, we have the neutralize ability, this means k is more than 0, and x is a negative value. So this means this coin is a negative value. So this means we're gonna use the neutralize ability. So we're gonna choose the maximum of the result with this one. Let me just copy and paste. Yeah, so in this way, it means if we use the neutralize ability, we will not collect the coin, so we will not plus this x value. Yeah, so from here, because we're gonna use the neutralize ability, so this k value gonna minus 1, and similarly for here, this k gonna minus 1, and finally we're gonna return the result. Yeah, so this is the entire code. As we can see, there's not so many checking. So basically, this is one thing we need to take care, because inside the coils matrix, they're going to be negative values. So we're going to choose a negative infinity. And also here, we need to be careful. So if we go to the add position, r equal to 0 and c equal to 0, and we have to check this k. If we have the neutralize ability, so we're going to use it. So we're going to choose a maximum x with 0. So in this condition, it means if x is a negative value, we're going to choose 0. If x is a positive value, we're going to choose x. Otherwise, if we don't have the neutralize ability, so we're going to directly choose this value x. Yeah. And here is for collecting the coin, and here for using the neutralize, so we will not collect the coin. So this is for not collect the coin. Now let me just run it to check. As you can see, it works. Now let me just submit it to check if it can pass. As we can see, it passes for all testing cases, although it is a little bit slow because the time complexity is R times C. And for this R and C, it's going to be a really big value. So this R and C is going to be 500. So that is why it is so slow. It's going to be R times C times K. So basically, it's going to be, yeah, it's going to be like 10 to the power of 5. That is why it's so slow. I think that's all about it. Thanks for watching. See you next time.